The domains of logarithmic functions. Our objective for this video: determine the domain of a given logarithmic function. Okay, so what do we know? We know what a logarithmic function is. It is any function of the form f of x equals log base b of x, where b, the base, is positive but not equal to 1, and x, the argument, is positive. The argument is positive here. And we know that the domain is the set of all positive real numbers, which means from 0 to positive infinity in interval notation. However, that's in the base equation. But we can have some different, if the argument is more than just an x, we have to be able to determine the new domain for it, okay? So the entire argument must be greater than 0, but we're going to look at arguments that are not just an x, that have more going on, okay? So as above, the domain of the logarithmic function is the set of all positive real numbers. That's here. In the general equation, as I just alluded to, which is this equation, this means that the argument, which in this case is just an x, must be greater than 0. If the argument is different, it still has to be greater than 0. So let's take a look at a couple of examples that have more going on in the argument than just an x. Okay, argument. This is what you want to remember. The argument is greater than 0. Okay? So let's take a look at first example. Find the domain of f of x equals log base 4 of x plus 3. Okay, this is not just an x. Now it's x plus 3. We want to write this domain in both interval notation and set builder notation. So this is our argument right here. And what do we know? Our argument, which is x plus 3, must be greater than 0. So x plus 3, the argument, I'll label that here, argument, is greater than 0. We subtract 3 from both sides, and our domain, x, the x values, must be greater than negative 3. Okay? So the domain is all x's that are greater than negative 3. On a number line, we'll put a negative 3 here. We'll put 0 here. We need greater than negative 3. And so we're looking like this. Okay, on a number line. In interval notation, we can't include negative 3 because it's greater than negative 3. So we put a parenthesis and we go from negative 3 to infinity. In set builder notation, the set of all x's such that, so we always start off with our curly brackets, our letter, and our bar that stands for such that x is greater than negative 3. Okay, so here's a number line version, interval notation, and set builder notation. And as a reminder, this argument is more than just x, so we had to do a bit of math to come up with what our domain is. Let's look at a second example, because this tends to make a fair amount of sense as long as you recognize your argument must always be greater than 0. Find the domain of f of x equals log base 10 of 2x minus 5. Write the domain in both interval notation and set builder notation. Well, here's the argument right there. That determines our domain, and we know the argument must be greater than 0. So 2x minus 5 has to be greater than 0. So let's solve this for x. I'll add 5 to both sides. 2x must be greater than 5. I'll divide both sides by 2. X must be greater than 5 halves. Okay, number line. Put a 0 in there. 5 halves is a positive number. I'll put it right here. It's of course 2.5 as a mixed number. X must be greater than 5/2, so open circle, and we'll shade off to the right. That's the number line answer. I asked for interval and set builder. Interval means greater than 5/2, so 5/2 is first, with an open parenthesis because it's not equal to, and then it goes to infinity. In set builder notation, the set of all x's such that x is greater than 5/2. Okay, so the key part of this, so as you look for the domain of a log function, the key piece of this is right here. Your argument must be greater than 0, and you may need to do a touch of math here and here to come up with the x values that meet that criteria that tell you that are within the domain of that particular logarithmic function.